Hey there! In this video, we're going to talk about composition of functions and algebraic operations on functions. So we're going to start with last one there I mentioned, algebraic operations on functions. Now, this isn't really any different than a lot of things we've already been doing this class, only we're using a different notation now. We're bringing in function notation. And so really, you're using a lot of things you already know how to do. We just got to get used to this new way of writing out what it is we're doing. So I can take two functions and add them together. I can subtract them, I can multiply them, or I could divide them. Now, on each four of these equations, there's two different ways of expressing that operation between those two functions. The right side is more of a longhand, where I have f of x plus g of x or f of x minus g of x. The left side of each one of these is a shorter hand notation to represent the same thing. So instead of saying f of x plus g of x, we can say f plus g of x. So it's a little bit less writing and a little longer, a little shorter thing to say when we're writing this. But these do mean the same thing. So whichever way you see them, you hopefully will understand what they're asking you to do. So let's do an example where we take two functions and do each one of these operations on them. So here we have f of x equals x squared plus 2x and g of x equals 6 minus x squared. And we're going to find what f plus g, f minus g, f times g, and f over g is. So we'll start with the f plus g of x. So I'm really just taking and adding the two functions together. So x squared plus 2x plus 6 minus x squared. And then I'm going to combine like terms to simplify this as much as possible. I see I've got an x squared and a negative x squared, so those are going to cancel out. And I get a final answer of just 2x plus 6. Next up is f minus g of x. And again, I'm just subtracting the two functions. The key with this one is I need to distribute the negative in the subtraction to everything in the second function. So it should read x squared plus 2x minus, and then in parentheses, the second function. So here that is 6 minus x squared. To simplify this, I've got to distribute that negative to everything in the parentheses. So it becomes x squared plus 2x minus 6 plus x squared, in which case, when I combine, instead of the x squared terms canceling out, they actually combine to give me 2x squared. So I end up with 2x squared plus 2x minus 6 as a final answer. Next up is multiplication, f times g of x. Okay, I'm doing distributive property here. I've got x squared plus 2x times 6 minus x squared. So I got to distribute everything out here, and I'm going to get four terms from distributing. So x squared gets distributed to the 6 and the negative x squared, and then the 2x gets distributed to both of those terms. So that's going to give me 6x squared minus x to the fourth plus 12x minus 2x cubed. And you can rearrange the order if you wanted them in descending order with the highest degree term first, but it doesn't really matter. The answer is the same either way. There's no like terms there that I can combine. The last one is to divide functions, so f over g of x. And so I'm literally just writing these two as a fraction with f of x in the numerator and g of x in the denominator. For good measure, it's always a good idea to try and factor as much as you can to see if there's any cancellation that goes on. Here, the only thing I can factor is I could factor an x out of the numerator. I get x times x plus 2. But the bottom really doesn't factor into anything nice and definitely doesn't cancel with anything in the numerator. So either one of these answers here is acceptable for a final answer. Just make sure that you've canceled as much as you can, simplified it before moving on. Okay, those are algebraic operations with functions. Next up is composition of functions. And this one tends to be a harder one to wrap our brains around. This and the notation you see here, I've written it in two different ways. The left-hand notation is the common shorthand for this. It's the one you'll most likely see in like a homework question. But the right side is really kind of explaining what the composition of function means. So that composition symbol is a little circle in between them. So f composed with g is how I'd read that. But it's just a little circle, almost like a multiplication dot, but should have a hole in it. Sometimes you'll hear people refer to this as fog, And if you reverse the f and the g, you get goff. So you might hear that somewhere, but we're really just talking about composition of functions. Now, what composition of functions means is I'm going to take the inner function g, and whatever I get from evaluating that function g at x, or whatever x value I'm given, I would then plug into the outer function f, the one that comes first in the notation here, and then see what I get out of that. Okay, so f of g of x is the longhand of that composition. And it's always a good idea to think about things like domain in these cases. So the domain of f composed with g is all x in the domain of f, such that f of x is in the domain of g. So that's a mouthful. But basically, if I can plug it into g, and whatever I get out of that, if I can plug it into f, that's in the domain. Okay, so let's do an example with composition of functions. Here I've got a function f of x is the square root of x plus 4, and g of x equals 2 over x. When you're given an actual number to plug in to this, like here we're being asked to find f composed with g of 2, what you're going to do is you take that x value 2 that they've given us, and you're going to plug it into the function that's closest to the 2. So here it's the g. So I'm gonna take 2 and plug it into g of x, and get g of 2, which would be 2 over 2, which is just 1. So that's my y value that I get out of g when I plug in 2. And so the composition means that I'm going to take that 1 that I got out, I'm going to plug it into the second function, f. So now I'm going to find f of 1, okay, remembering that 1 is g of 2. So if I plug that into the function f of x, I get the square root of 1 plus 4, which is the square root of 5. So f composed with g of 2 is the square root of 5. Now it gets a little more complicated when you're asked to do this with the variable x, but we'll practice that in the homework and in videos and in class if you're in my in-person class. Okay, there's a couple of examples below this video for you to practice this a bit more.